Lesson 10.4 is about circle constructions. Okay, the first construction in this lesson is our 8th construction in this unit, and it's to construct a tangent to a circle through a point on the circle. So I have the blue point on the circle, and the first thing to do is to connect a radius and then extend it out from the center of the circle through the point. And extend it nice and far so you have plenty of room. Then we're going to make that point that's on the circle the center of a little mini segment, and we're going to do a perpendicular to it, because we remember that the radius of a circle is perpendicular to a tangent at the point of tangency. And we're going to let this blue point represent the point of tangency. So what you do is you put your compass tip on that point, and you choose a small and convenient radius, and you swing to the left and you swing to the right. And this is a perpendicular bisector construction. We make these like the endpoints of our own new little mini segment. And from there, we swing up, swing down from the one on the left. Then we move our compass tip to the one on the right, and we swing up, swing down. Now we can connect through those points and through the point on the circle, and we've now created a 90-degree angle, a perpendicular to it, and that red line, this one, represents the tangent. Okay, in this next construction, construction number 9, I want to construct a tangent line, and there's actually going to be 2 tangents from any point outside of the circle. I want to go from point P to the circle with tangent lines. So the first thing to do is what I did in the last construction, which is to connect from the center of the circle a segment that goes all the way out to point P. Then what I want to do is I want to find the midpoint of that segment. So I do a perpendicular bisector of that segment by putting the compass tip on the center of the circle and choose a convenient radius more than halfway across, swing up, swing down, then put the compass tip on point P using the same radius, swing up, swing down. That is going to give me a perpendicular bisector of that segment, and it will contain the midpoint of the segment. Okay, so let's call that point M. Now, the way to find the tangent points on the original circle is that we now use point M as the center of our own new circle. So we set the radius to MP. So in other words, we put the compass tip here and we set the radius to point P, and we then go and draw a circle. Okay, and that's not a very well drawn circle, but you get the idea. It has M as its center and the radius is MP. Well, the point in which that circle intersected our original circle are the 2 points of tangency. So now we can connect them back to point P, and they of course are equidistant to each other, but those two, this one here and this one, are the 2 tangents to the circle from point P. Okay, construction number 10 is if we're given a triangle, we want to circumscribe a circle around it. So we have to find a point inside this triangle that will be the center of our circle, and that circle will intersect our triangle at each of the 3 vertexes. So what we do is we need to find the point of intersection of all the perpendicular bisectors of the triangle. Now, we know all 3 will intersect in one place, so we really only need to find 2 of them. So I'm going to take the bottom side, look at these as endpoints, adjust my compass radius to be more than halfway across that bottom segment, and I'm going to swing up, swing down, and then go to the right one, swing up, swing down, and find a perpendicular bisector of that bottom side. Now I just have to do it with one other side, so maybe I'll do it with the side that's on the left. From one side I'll swing up, swing down, and from the other endpoint I'll swing up, swing down, and I find perpendicular bisector of that side. Now I don't even need to do this to the third side because I know that they're all going to meet in the same place. Now that becomes the center of a circle that will circumscribe around that triangle. So what I now do is I set the radius length to be from the center here out to any one of the angles, vertexes, and that's my radius length. Then I draw my circle, which should circumscribe around that triangle perfectly. Okay, so to recap those steps, I bisect two sides of the triangle. I find the point of intersection of those two perpendicular bisectors. I set the radius equal to the distance between the point of intersection and any one of the angles, and then I use that radius to draw a circle. Okay, our last construction here is when given a triangle to inscribe a circle inside of it. So in the last construction, I bisected the sides. In this construction, I bisect angles. So I just need two, so I'm going to arc maybe these two angles and bisect each of them. So using my anchor points, swing out, swing out, swing out, swing out. Okay, so those are going to meet those angle bisectors in one place, in the center, somewhere in the middle of the triangle. And we don't need to do the third angle bisector because we know that it's going to be intersect in the same spot. Okay, now what I want to do is set the radius equal to the distance between the point of intersection and a side, but I have to hit a side at a perpendicular. So I need to use a perpendicular bisector. So what I'm going to do is take this bottom side and find its, I want to go perpendicular to that segment through this point of intersection in the middle. So I'm going to do this in green. I'm going to put my compass tip here on the point of intersection, choose a small radius that will hit that bottom side in two places, swing left, swing right, and create two anchor points. And then from those anchor points, swing down, and I actually will form a little perpendicular segment. I call that the cat's tail. It looks like a cat's tail hanging off a fence. Now, the distance from here to here, from the point of intersection to that side, is the shortest distance to a side. That's what I set my radius to. And then I can swing around and it should inscribe a circle nicely inside of that triangle. And that is it.